Hello everyone, I'm Sedrick from Carnegie Mellon University, and today I'd like to talk about our project, NewsPanda, Media Monitoring for Timely Conservation Action. This is a joint effort between the Worldwide Fund for Nature and Carnegie Mellon University. To start, I'd like to talk about an issue WWF country offices are facing. They spend a lot of time reading through news. They read through news to identify trends, events, or threats related to conservation and infrastructure. And this process from start to finish, from selecting articles to reading the articles to extracting insights from the articles, takes a lot of time. Identifying 7 to 10 articles can take around 2 to 3 days for a person to complete. And so having a tool that can automate this process is really helpful for WWF to be able to more effectively allocate the resources to what they do best, which is taking action on these articles. So the research question we wanted to solve was, how do we identify and analyze media articles for timely conservation and infrastructure actions? Now, conservation, we all know, is things such as natural disasters, habitat destruction, and so on. But you might ask, why are we concerned about infrastructure? This refers to things such as roads, railways, pipelines, and so on. And the reason WWF pays so much attention to infrastructure is because these developments are usually very high impact and very long term. Think, for example, a railway being constructed. And when these developments are covered in the news, the articles are usually for upcoming or ongoing developments, as compared to, let's say, a natural disaster, which is something that happened in the past. And so because it's upcoming, this is an area where WWF can truly perform the necessary interventions and take part in the relevant conversations. And so it's really, really important to identify these in a timely manner. The solution we came up with was a toolkit, which we call NewsPanda. NewsPanda automates multiple steps in this pipeline, from scraping and extracting articles to classifying which articles are relevant to performing some basic analysis and insight extraction. And this really frees up the humans in the process to do the crucial tasks of high-level analysis and really acting upon these articles. Here we see the pipeline of NewsPanda. There are 5 key modules in the pipeline, which we'll be going through later on. And this entire pipeline is ran on a weekly basis. Before we go through the pipeline, we'd like to start by talking about our data set. As mentioned earlier, we're concerned mainly on conservation relevance and infrastructure relevance. First, we use an existing data set covering World Heritage sites from around the world. We call this the WHS Corp data set. This has 928 articles that are labeled for conservation relevance. Now, because we're not only concerned with conservation, but also in infrastructure, well, we create our own data set called the InfraCorp dataset. We're working closely with WWF India and WWF Nepal, and so InfraCorp focuses specifically on articles in India and Nepal. We scraped around 4,000 articles using the News API scraper and select 1,000 of these articles to label for both conservation relevance and infrastructure relevance. Now, going back to the pipeline, the first step in the pipeline is information retrieval. This means selecting the articles every week. Now, this is quite straightforward. We use the News API scraper, and to search for the articles, we use the names of the conservation sites. These names are taken from a curated list provided by WWF. As mentioned earlier, we focus mainly on India and Nepal, and we run this on a weekly basis. Now that we have a list of articles for each week, the next step would be to classify which of these articles are relevant to conservation or infrastructure and which of these articles are not. Now, for conservation relevance and infrastructure relevance, we use the same backbone model, but different models for both. So once we have the article, we then extract the BERT embedding. Specifically, we use the Roberta model. Then we also extract the topic modeling vector as well as the sentiment analysis score, and these are just to enhance the embedding. Then we concatenate these 3 features and pass it to a final classifier, which gives a binary prediction to tell us whether it's relevant to conservation or not, and whether it's relevant to infrastructure or not. Here we see the results of NewsPanda compared to our other baselines. So for the baselines, we use BERT, Roberta, some RNN-based models, as well as some keyword matching models. And as we can see here in the tables, for both conservation relevance and infrastructure relevance, NewsPanda performs the best across all the models and the baselines for precision, recall, and F1. Now, while training, there are also some crucial design choices that we made. Specifically, if we recall the InfraCorp dataset, we had 4,000 articles, but we selected only 1,000 of them to label by 2 domain experts at WWF. Which this leads us to 2 key questions. The first is, how do we best select which of the 1,000 articles to label? And the second is, since we have 2 people labeling each article, how do we best handle label noise in our annotations? For the first question, the solution we came up with was something called confidence-based active learning. This basically means using the existing WHS Corp dataset with the conservation relevance, we train an initial model. And using this initial model, we're able to rank the articles in the InfraCorp dataset. And from this ranking, we select the 1,000 most difficult articles for the experts to label. The hypothesis is that if we train with these more difficult articles, then that can help the model learn better and better increase the performance. To verify this, we conducted an ablation study. We had a set of 300 actively selected articles and another set of 300 randomly selected articles. From this table, we see that if we add the actively selected articles compared to if we add the randomly selected articles, adding the actively selected articles gives a higher gain, a larger performance gain. And this is consistent with our hypothesis that indeed training with these harder data points will help the model to learn better. For the second question of handling label noise, our solution was to adapt the core-squared loss from Cheng et al. This is a noise correction algorithm that's an extension of the peer loss algorithm. How it works is it frames the task of learning from noisy labels as a peer prediction problem. You can find the formula here and more descriptions in our paper. To verify this, we also conducted an ablation study where we compared using the core-squared loss versus using the peer loss versus using no noisy label correction at all. From the table, we once again see that using the core-squared loss gives the best performance in terms of F1 score compared to using peer loss and using no noisy label correction. And this once again is consistent with our hypothesis and that core-squared loss is indeed helpful. Now that we have identified which of the articles are relevant, we then go to the article post-processing module. So here, for each relevant article, we extract keywords. We have an event extractor as well as a geolocator. So our keyword extraction is pretty straightforward. We use a basic keyword matching algorithm where we have a list of around 1,000 keywords created by WWF together with the corresponding categories. So in the example paragraph here, we see, for example, the keyword tiger and the keyword forest together with the corresponding categories, species, and terrestrial habitat. Next, for each relevant article, we also identified the named entities using a BERT-based NER model. Also here we see some examples, and not only are we able to identify the named entities, we're also able to identify whether it's a location, an organization, a person, and so on. And the keywords and the named entities are really cool because we're able to then create these event graphs where if we select the cliques in these graphs and sort it, we can come up with a timeline as seen here. So in this example, we use the entity Subansiri and filter with the keyword hydroelectric. And we find these 4 articles. So in the first panel, we see, for example, in this area, this dam is being constructed and all hurdles were removed. This was February of 2020. In the second panel, in December of 2020, it said that it will be commissioned by March 2022. A few days later, another article that it's being expedited. And lastly, in the fourth panel, in January of 2021, we see that the construction is starting. And lastly, we're also able to do geolocation. And this is really important to be able to integrate NewsPanda's results into WWF's existing GIS systems. Also, to do this, we have a directory of that maps conservation sites to coordinates. And so we just use this mapping, and if there's no match in this mapping directory, we use the GeoPy package. Lastly, we have our visualization module and our social media module, or what we'd like to call our deployment modules. So we have 3 stages of deployment starting February 2022. These are our pilot study, our initial deployment from March to July, and our sustainable deployment starting from August 22, and it's currently ongoing. So in our initial deployment, we were able to have the WWF teams evaluate the articles classified by NewsPanda. We sent them these lists and asked them to identify whether or not NewsPanda's positively relevant articles are indeed relevant, and whether or not NewsPanda may have missed out on some potentially relevant articles. Using these results, we're able to come up with this table. And what I'd like to point out is that the precision values for both conservation and infrastructure are generally quite high, and this is really crucial for building a trustworthy and reliable system. This tells us that the articles NewsPanda identifies as relevant are indeed relevant. Meanwhile, the recall for infrastructure is quite low, which tells us that we might miss out on some potential articles, and this is something that we're currently working on to help identify more positively relevant articles. We were also able to conduct a survey with WWF to ask them what they thought of NewsPanda. What I'd like to point out here in the first 2 panels is that we're really able to increase their efficiency and their output. So for example, in the first panel, we see that they'd spend 2 to 3 days a week previously on 7 to 10 articles, while now we're able to give over 50 articles a week, which is a really big boost in their output. And in the last panel, it says they will not just be doing data hunting, they're qualifying themselves to be data analysts. And this is really one of the main goals of NewsPanda, as I mentioned earlier, that we really want WWF to be able to allocate the resources in the best way possible so that they can do what they do best, which is analyzing these articles in a deep level and acting upon these articles. So here we see the visualization. So this is an existing GIS system that's built by WWF. And what's cool is that NewsPanda's articles are able to be seamlessly integrated into WWF's GIS system. So in this map, for example, we see these red areas, which are areas that are flagged by NewsPanda. And this is useful for WWF's field teams so that they can know which areas to investigate. And we're really proud to share this success story we have from August 2022. When NewsPanda highlighted this area, Ikala block boundary to Lopara Road, and when WWF investigated it, they found that the project would divert 5.9 hectares of forest land. And most importantly, WWF found the project while it was at its pre-proposal stage, which means that WWF would be able to take early action and really participate in relevant conversations to ensure that the proper measures are being taken before this project starts going underway. Lastly, we have our social media module. This is to share NewsPanda beyond just WWF for the general public, for other organizations who might also be interested. So to do that, we built a Twitter bot. The handle is Wildlife News IND. We share articles every week together with relevant keywords and hashtags. So go ahead, feel free, like, share, follow. And lastly, for our current steps, we're really looking to expand it into more languages and more local media sources. And this is something that we're really excited about and that we think is very important, because if you look at India, if you look at Nepal, a lot of the key developments don't reach international news. And so they might not be covered by a weekly news API scraper. And a lot of them might be in their local news sites, written in their local language. And so it's really important for us to be able to also process these articles. And to that end, we're looking at multilingual language models such as multilingual BERT and XLMR, and our initial results show good generalizability to other languages. And an ongoing challenge that we're currently facing is Now that we have this English NewsPanda model, how do we expand it in a few shot or a zero shot manner to work on other languages? So that's something that we're working on, something that we're really excited about. But for now, we'll leave it here. This is NewsPanda. Thank you very much for listening.